Hi guys, I'm going to be your little extra lab partner taking you through the process of getting your presentation ready for tomorrow. Step one, get your data ready. It should be close to ready, but you might need to do a few tweaks. Take out your data, pause the tutorial while everybody gets it ready, and look and see if you have all the things you need to on your data table. First of all, you're going to need a nice neat one so that you can get all the points on the rubric for this. And it needs to have a title, and it needs to have labels similar to mine. Now, you're not going to have the same title because you tested the effects of, I'm guessing, not ramp color on the average velocity of the ball, but something else, like maybe ramp height. So whatever your independent variable was, you're going to replace ramp color with your independent variable. You're going to do the same thing here in this part of the data table. You're going to write your independent variable there, and instead of your two ramps being brown and green, your two ramps are going to be whatever the difference was between your control and experimental group. It says in your data table, or should say, what your units are for velocity, and you probably are going to need units for your ramp variable, whatever that is that you changed. Mine didn't happen to need units because colors don't come with units, but if you measured height, for example, you would want to have units of centimeters, let's say. Okay, now after you have your data table out like this and you've made sure it's set up nicely and everything so that you can take a good picture of it for your presentation, the next thing you're going to want to do is figure out which one of the numbers do you want to take from the mean, median, and mode section. So for my brown data, I had 0.531, 0.390, and 0.390. I could choose any one of those numbers as representing the entire run of data. And I'm going to choose median because my mean is way higher than most of my data, and that's because of this weird outlier that pulled my mean way up. And I'm going to choose median over mode just because mode is only really useful if you have many, many numbers repeating themselves. And I only have a couple of repeats in this data set, so my mode I don't really trust as much as I trust my median. So I'm going to go with the median as being the best representation of this brown data, and that's 0.390. On the bottom, I didn't have any outliers. My numbers were all really close together. But again, I don't like the mode. I should have crossed out the mode on the top as well. I apologize. There we go. I don't like the mode because I don't have very many repeated numbers to begin with, so I'm not really confident that the mode represents the data very well. My mean is pretty good, actually, but since I picked median on the top, I figure let's be consistent and pick median on the bottom. So I'm going to be comparing 0.390 meters per second. That's the median speed of the brown ramp, I should say, with 0.195 meters per second. That's my green ramp. And because I made this data up, it looks like that worked. But of course we know in reality, that's not going to work. A green ramp isn't going to go slower than a brown ramp. Just make sure you realize that. Okay. So once you have picked out those numbers, what are you going to do with them? Well, you're going to make a graph. This is a bar graph that I made using a website called Create a Graph. I'll show you how to access that in a second. But before I do, just take a look at your rubric. Pause the tutorial, break out the rubric for this lab, and notice that there are lots of points under supporting details and under elements of presentation for doing a good job with your data table and your graph. Look at it, make sure that you're doing everything you need to do. My data table and graph both have titles. My data table and graph both have labels of my variables. On the graph, it's on the X and Y axis. On my data table, it's in the different boxes. And I included the units of the things that I measured. So I have meters per second for my velocity and centimeters for my height. Check and make sure all those details are present on your data table and your graph. You'll thank me later for doing that. Okay, so you could draw this graph by hand, but that would require some decent math graphing skills to figure out what the scale is going to be. Computers do this better than humans do. So my recommendation would be that you use this Create a Graph tool. Here's how you get to it. Go to Google and type in create a graph. This website should show up. Click on that. Go ahead and click on bar graph because that's the kind of graph you want to make. After you click on bar graph, you're going to get something that looks like this. It looks like a big old hot mess, lots of information. You don't actually need to do anything on this screen. You just want to click the word data, and that'll open up a new screen for you. In the data section, what you want to do is you want to choose so that you have one item and two groups. You're going to put your title in where it asks for the title, your x-axis label and your y-axis label. Don't forget your units. And then these colors, I can't figure out how to change them. They're just kind of default colors. Maybe you can figure it out. You're going to label your groups. So my groups are my control and experimental groups. I have a brown group and a green group. You might have a tall ramp and a short ramp, or a short drop height or a high drop rate or something like that. In my case, my group labels aren't numbers, but yours might be, and that's okay. But if they do have numbers, you might want to include units with them. So if your group labels are a height of 75 centimeters and a height of 39 centimeters, well, then you want to put centimeters in them. Then your item label is going to be your independent variable. So my item label was ramp color. Yours will be whatever you happen to choose, probably ramp height for most of you, it seems like. And then what you're going to do is you're going to plug in your values for your brown and green group. Remember, we picked the median, so I picked 0.390 meters per second. That was the median speed of my brown ramp, and 0.194 was my median speed for my green ramp. And unfortunately, the colors don't match my colors, right? After you plug that in, don't worry about minimum value and maximum value. Don't worry about source. Source is if you were to take this data from somebody else, you would want to say where you got the data from. We took the data ourselves, so we are the source, so we don't need to name ourselves. After you're done with that, there's a preview button. You're going to click that, and that's going to show you what your graph looks like. And if you entered everything correctly, it should look like this. Ta-da! See, it makes the scale for you. And you'll notice that if you entered everything as you should have, you have, whoa, I was trying to grab this tool. You'll see you have your title, you've got labels, including units, you see I have meters per second. Your two groups are shown here, my brown group and my green group, even though the colors don't match. And it even tells you up top what numbers these are, 0.39. It's on the side here on the y-axis. That's my speed. And over here, 0.194 is my other speed. And you can see, so that you don't have to actually read the graph, it just puts the number there for you. So this is a beautiful way to make a bar graph. So after you're done with that, it's time to go plug everything into your presentation template, which is in Google Slides. So let's do that. As I mentioned before, you're going to want to have the rubric handy while you're doing this. Put somebody in charge of watching for certain things. It might be a good idea to give each person in the group a responsibility, like somebody's in charge of elements of presentation, somebody's in charge of half the supporting details, and somebody else is in charge of the other half. And then somebody else can be in charge of double checking the higher level thinking, or you can all double check it together. Break it up however you want, but make sure somebody's paying attention to the rubric. It should really be all of you, but work together as a group and make sure that you're getting it done. So you'll notice, as I mentioned before, that the data table having units, labels, and titles is graded as supporting details. And everything being neat and easy to interpret is also graded. So that's really, really important. I'm going to keep referring back to this rubric, so make sure you have it handy. Okay, something easy. Go ahead and put everybody's name on this slide. So open up the Google Slides, go ahead and create your presentation. I recommend that everybody do it in their own iPad so that tomorrow when 3 people decide to be absent because they're scared of giving the presentation and you're all by your lonesome, you can just open it up on your iPad. Everybody's name should go in here. Make sure you spell everybody's name correctly and that you do both first and last name. Next slide. Okay, this should already be done. You were supposed to come up with a hypothesis and a rationale. Go look at the rubric, make sure you're going to get all the points for your hypothesis and rationale. There's two places. It's supporting details and under higher level thinking. Under higher level thinking, what I'm looking for is that you're making sense. So if I had put my hypothesis down about the fact that I seem to have thought that the ramp color would make my ball go slower, that's kind of a ridiculous hypothesis. So it's unlikely I would have a logical rationale for that. I would probably say something like, well, green is my favorite color, so I thought that the ball would roll more slowly down the ramp because it would be admiring the color green on its way down. Totally not logical, and you would lose points for that kind of a rationale, right? You don't have to be right. Your hypothesis doesn't have to be correct, but it has to make sense given the universe we live in. So double check that. Okay, so this is going to go on this slide. You're going to write it nice, neat, organized. Make sure you pay attention to the fact that it should be proofread. There should be no spelling or grammar errors, and then you're good to go. Next slide. Okay, guys, let's be careful here. Remember when we did the first fair test lab where we dropped balls and to see which one would land first, the heavy one or the light one? Well, I had people get up and present the procedures of another group or try to do the procedures of another group, and I hope that that taught you that you have to really be careful how you word procedures. You are being graded on how well your procedures are worded. Under supporting details, you'll see that it says procedures are detailed enough that a 7th grader could run a fair test of the question with only your instructions and the materials you used. So picture that 7th grader. Are you being clear? Are you giving them the right information, right? And have that person who's in charge of the presentation, of the writing and the proofreading, make sure they look over these procedures to make sure that they are well written, clear, and make sense. And under higher level thinking, you see that second line in higher level thinking, experiment shows a full understanding of how to conduct a fair test. This is where I'm going to be measuring that. I'm going to read your procedures and ask myself, hey, do they have a good system for measuring what they want to measure? Do they have confounding variables? Do they have missing information? What's going on here, right? So think about all the things that make a test fair. Don't go back and change your procedures now. If you've decided that you did not run a fair test, there'll be a place for you to correct for that later. But do make sure it's very clear what procedures you actually ran. That's super important. Okay, this should be a numbered or bulleted list. I prefer numbered lists so that way we can talk about it. I can say, well, when number 3, you did this and explain to me like that. Okay, procedures are super important. Lots of points for doing a good job with these, so take your time with this. Next slide. Okay, now it's time to make a claim. So the question here is, did you design and carry out a fair test? So it doesn't matter whether or not you were right about your hypothesis, because actually I don't want you to make a claim about your hypothesis, which is weird because usually scientists are making claims about whether or not their hypothesis was supported, but you're not. You're investigating whether or not you ran a fair enough test that you could make such a claim if you wanted to. So did you design and carry out a fair test? This is very similar to what we did with the other experiment titled a fair test. Go back through your procedures, think about it. Do you think that this test was run in a way that you trust the data to be giving you a true answer? Once you decide that, go ahead and write your claim. It'll sound like this. Either it will say, this experiment was a fair test, or it'll say this experiment was not a fair test, or something like that. Next slide. Okay, what you're going to do for your evidence slide depends on whether or not you think you ran a fair test. It's important that you choose wisely because I'm going to be grading you on whether or not you recognize whether or not you ran a fair test. So if you didn't run a fair test, own up to it. If you did, be prepared to defend the fact that you did. So your evidence is going to look a little different than it did last time though. Let's say that you think you did run a fair test. Maybe you did. We were much more careful running this experiment than we were with the last one. So if you think that that's the case, then you probably feel like you can draw a conclusion from your data, and that's going to mean that your data is now your evidence. So you're going to put your data table and graph here. You should do that even if you think you ran not a fair test, but then you're going to talk about the fact that you can't trust your data. So this slide will have your data table and your graph, as big as you can get them next to each other. And you're going to be talking through this slide about your data and whether or not it was collected fairly. Remember, your previous slide was your procedures. So when you had your procedures slide up, you'll just be talking us through how you ran your experiment. But then when you bring this slide up, you're going to combine your procedures with your data and talk about whether or not those procedures gave you data that you feel you can trust. Then, once you're done with this slide, you're going to talk about your reasoning. Be careful, everybody has a tendency to try and do their reasoning here in the evidence section. It's not a big deal, but you really shouldn't be explaining why you have a fair test yet. You should just be saying, hey, look, these are all the fair things, and then you'll talk about why those things make a fair test in the next slide. Okay, so this is a presentation, right? So you should be using as few words as you can on this slide. It's tempting to just write a paragraph here and then read it to us, but that's not a presentation. That's a paragraph. Nobody likes reading stuff on a slide while someone else is talking. It's impossible to both read and listen at the same time to two different things. So what you want is to just put your main points up here. What are the reasons why your test is not fair? You're going to reference your evidence, right? Or if your test was fair, what are your reasons for why it was a fair test? So you'll be talking about things like confounding variables and why confounding variables can mess up the fairness of a test. You'll be talking about things like repeating the trials multiple times to make sure that there are no fluky things happening, right? All of those things that make a test fair are what's going to go into this slide. I recommend just a quick bullet point of each point that you want to bring up, and then the person who's going to speak is going to talk in more detail about those things. Okay, look at your rubric under Elements of Higher Level Thinking. I've already talked about the first two things, right? You should have had a hypothesis and a rationale that was clear and logical. And then your experiment should have shown an understanding of how to conduct a fair test. If your procedures were not fair, then in your evidence slide, you talked about how they weren't fair. And so I'm able to know by the time we get to this point in the presentation that you understand what it takes to run a fair test, even if you didn't run one. The last three things are where the rest of the higher level thinking points come from. Your claim should be clearly stated. I don't see how you can somehow not get these 4 points because I basically told you that you're either going to write that your claim is that you ran a fair test or your claim is that you didn't, and that's pretty simple and clear. But your evidence is relevant to your reasoning. Well, your evidence, remember, is going to be a combination of your data, which you're going to show on the slide, and references to your procedures, which are not going to be on that slide when you're talking about them. Because whether or not a test is fair has everything to do with the procedures you used to collect your data. So this is tricky. Make sure that the evidence you're presenting on that slide supports your claim. Make sure of that. And then your reasoning demonstrates an understanding of how the evidence supports the claim. So on this slide, you should be making connections between, hey, look, we collected data very well. We had no confounding variables. That's our evidence. Here's my reasoning for why that's a good thing. When you have no confounding variables, you can be sure that the variable you're testing is the one that's causing the change in the dependent variable. You might not say it as fancily as I did, but you want to make the point that you get it. You understand why confounding variables mess an experiment up and why not having any is a good thing. And you're going to do that for each piece of evidence that you have on this slide. Now, when it's time to present, everybody in the group should be responsible for some of the presenting. And you really need to force people who are shy and quiet to do their fair share. Everybody has to be able to present. At the end of the year, you're going to do a project for me where you all by yourself, without any group mates, are going to have to record yourself presenting an 8 to 10 minute presentation with nobody else there but you. So you have to learn this skill. So don't put it off on your group members. And don't get into a habit of just reading what's on the slide. Be prepared to say something off the cuff from your own memory as if you're comfortable up there speaking to us. It'll make all the difference in your grade. Okay, guys, I hope that's enough information for you to get through the presentation. And I hope that when I come back on Tuesday, you'll be ready to go. Remember, everybody should have their own copy of the presentation. That way, no matter who's absent, even if there's just one of you there that day, everybody's ready to go. See you in class.